1 plus log of 3x minus 4 is equal to 0. First thing I need to do is get the constants over onto the other side. Now that I've done that, I should change this back from logarithmic form into exponential form. And this is a log base 10. So this will become eliminated. I'll be left with 3x minus 4 is equal to 10 to the minus first, which is 1/10. Now I add 4 to the other side. 4 is the same as 40 over 10. So I'll write this as 41 over 10. And then I divide by 3. And I'm left with my final answer. So that is that. On to the next one. Natural log of 2x minus 3 minus the natural log of x plus 5 is equal to 0. So for this one as well, I'm going to want to combine these logarithms and then write it back in exponential form and then solve for x. I can use the quotient rule to combine these logarithms. Ew. Man, I hate writing ugly letters. Zero. Now I can convert this back to logarithmic, or from logarithmic form back to exponential form. And this is base e. E to the 0 is 1. I'll multiply the denominator over to the other side, and this will just give me x plus 5. Now I get all the x's on one side, constants to the other side. X is equal to 8. So that is that one. On to the next one. Here I've got log base 6 x plus 2 plus log base 6 x minus 3 is equal to 1. Same procedure for this one, except these are being added together, so this will be a product rule rather than a quotient rule. I'll use the product rule here. Log base 6 x plus 2 times x minus 3 is equal to 1. Convert this back into exponential form. X plus 2 x minus 3 is equal to 6 to the first, so it's just equal to 6. And now I just multiply all this stuff out. X squared, and then this will give me a minus x, and minus 6 is equal to 6. Subtract 6 over. And this is just a regular quadratic problem. So the best numbers here would be 4 and 3. X is equal to 4, x is equal to minus 3. Now I have two answers. I need to check and see if I put these answers back into the original equation, if they'll still be in the domain. Because if it's not in the domain, then it won't work. If I get a negative number, the logarithm of a negative number, then that is something that is not in the domain and therefore won't be included in my answers. So I put x is equal to 4 here. I have 4 plus 2, which is 6, so that's fine. I put 4 in here. 4 minus 3 is 1, and that's a positive number, so that's okay. If I put in minus 3, I get a negative number in here, so already this is out of the question. In here I have a negative number as well. So this is not a solution, but this one is. So I have one solution, and it is x is equal to 4. So let me do one last one. Log base 7 3x plus log base 7 of 2x minus 1 is equal to log base 7 of 16x minus 10. So I'm going to use the same techniques as I did previously, but here I have 3 logs and I have to combine all of them. They're all the same base. 2 I can immediately combine are on the left side. I can use the product rule. So we log base 7 of 3x times 2x minus 1. Now I can subtract this logarithm over to the other side, and that will be a quotient rule. So if I subtract this from both sides, I'm subtracting it over here, and I can use the quotient rule. So to simplify this is log base 7 3x times 2x minus 1 this is now equal to 0. And now I convert it back to exponential form. Almost made a mistake. Because 7 to the 0 is 1. And now I simplify this, multiply this over to the other side, and multiply this out. So if I do both of those things at once, I'm going to be left with 6x squared minus 3x is equal to 16x minus 10. Now I bring these back over to the other side, and this will give me 6x squared minus 19x plus 10 is equal to 0. Now I need to factor this, and I really can't do this off the top of my head, so I'm going to use quadratic formula. Minus b plus or minus square root of b squared minus 4ac over 2a. So I'm going to fill in this formula. Where's that color I was using? Ah, there we go. So minus b, that's positive 19 plus or minus the square root of minus 19 squared minus 4 times 6 times 10 over 2 times 6. So let me simplify this step by step. So I have 19 plus or minus the square root of 19 squared is 19 times 20 is 380 minus 19, that's 161 or 361. So 361 minus 4 times 6 times 10, 4 times 6, 24, 240, so that's 121. So the square root of 121, which will be 11. 2 times 6 is 12. So this is 19 plus or minus 11 divided by 12. 19 plus 11 is 30. 30 divided by 12, 6. So that'll be 5 over 2. So let me do that. So 19 plus 11 over 12 is 30 over 12, which is 5 over 2. And then 19 minus 11 over 12 is equal to 8 over 12, which is equal to 2 over 3. 3. Now all that remains is to check and see if these in any way mess up the domain. So I'm just going to check the smaller number, 2 over 3. 2 over 3 here, that'd be positive. 2 over 3 here, that is greater than 1, so that's positive. And 2 over here, that's definitely positive. Or is it? 2 times 16 is 32 divided by 3. Yeah, it's greater than 10. So this is a solution. And then 5 over 2 is greater than 2 over 3. So if 2 over 3 works, then 5 over 2 works as well. So the solutions are 5 over 2 and 2 over 3.